quiz coming up here. A conditional is an if-then statement. If it is raining, then I'll need my umbrella. If I study for my test, then I will do well on my test. Things like that. So any if-then statement is called a conditional. The conditional is broken up into two parts, the if part and the then part. So like that first one, if it is raining, then I will need my umbrella. The if part, the if is called your hypothesis. The hypothesis is a word you've probably heard in science. It's kind of your educated guess. So if it's raining out, after the then is called your conclusion. So the then part is your conclusion. If it is raining, my conclusion is I'm going to need my umbrella. The if part, and here's where I kind of like to organize myself. The if I represent with the variable p. The then part, which is the conclusion, I represent with the variable q. So if p, then q. So P just represents the hypothesis of the statement. So P doesn't, in this case, represent like a number like we're used to with variables. It represents a statement, actually, the hypothesis. The Q then represents your conclusion. So we're going to take that first statement there, and we're going to rewrite it as an if and a then statement. First thing we have to do is we have to organize it into our hypothesis and our conclusion. So the first part of our sentence, Thanksgiving in the United States, I'm going to represent that as my hypothesis. So Thanksgiving in the United States, and then the second half of the sentence is the fourth Thursday in November. And that's going to represent my conclusion. Now we need to somehow, and this is kind of where it's your creativity, we need to somehow put this into an if-then statement. And if you've already done this problem and you maybe did a little different than this, there are multiple ways to do these, so don't get all worried, it's okay. I'm kind of running out of space underneath that problem. If you want to, you can just type underneath there, but I'm going to work up top here. So I'm going to say, if it is Thanksgiving in the U.S., I'm going to just abbreviate that. If it is Thanksgiving in the U.S., then it is the fourth Thursday in November. So there could be my if-then statement. So if it's Thanksgiving in the U.S., there's my hypothesis part, the first part. Then it is going to be the fourth Thursday in November. So there would be my conclusion. Now there is not just one answer to do this. If you maybe rearrange with a little bit different words, that's fine. You'll also notice on some of these conditionals, you can put the second part of the sentence as your hypothesis, and this first part could be your conclusion. That's still going to make sense. If you said, if it is the fourth Thursday in November, then it is Thanksgiving in the U.S., is that still going to be true? Yeah. What you did there is actually you're just doing a converse, which is something we're going to talk about here in a little bit. Converse is when you flip them around and check to see if they're still true. So if you did flip it around, that's fine. It's still going to be a true statement. But you got to be careful. Sometimes the conditional, if you flip it, it's not going to be true the other way. Like if I said to you, if an animal is a fish, then it swims. Is that true? Fish, do they swim? If I said to you, if an animal swims, then it is a fish. Not true. So you got to be careful. You got to really look at the statement. Is it going to make sense? But here, as you write this conditional, just know that if you're checking the key, your statement, if you put it the other way around, if it's the fourth Thursday in November, then it's Thanksgiving, you're going to be okay. You're going to be okay. There's going to be a little bit of leeway, a little bit of creativity that you're going to see in these statements. Problem 3, looking at those Venn diagram illustrations. So we're going to make a conditional based on those diagrams, and the overarching circle has a little circle inside of it, so the whole number's in there. The whole numbers is going to represent my hypothesis P. The integers, or the bigger, is going to represent my conclusion Q. So I'm going to say if a number is a whole number, then it is an integer. So that could be my basic statement there. So if a number is a whole number, then it's going to be an integer. The second one, the same thing. My wheat would represent my hypothesis. The grains is going to represent my conclusion. If a plant is wheat, then it's also a grain. Would be my statement. So the P and the Q just kind of help you keep track of if you're designating a certain statement as the P, that's your hypothesis as you move through things. If you designate it as the Q, that's going to be our conclusion as we move through things. So that could be our statements for 3 and 4. So hopefully that kind of helps you get in that mind frame of how the conditional statements are going to work. Now we're going to start taking those conditional statements and start to write what's called the converse, contrapositive, and the inverse. Am I okay if I delete this part up here? You guys all right with that? I can get that back for you if you need it later. 5 through 8, I like these. You're looking at a conditional and you're kind of playing the devil's advocate. You're trying to prove it wrong. So you're trying to see, is there anything that I can think of and prove it wrong? So kind of like that fish example. If I told you if an animal can swim, then it's a fish. You could probably give me a counterexample. What would be an animal that's not a fish that still swims? What could I say? A frog? Okay. So you could have any of those counterexamples. Okay. All right. Now we're moving on to 9. And here's where I just want to help you with the organization piece of this. So you looked at, in your notes, the contrapositive, inverse, converse. To help you organize, we're going to use that P and Q some more. So we're going to have a conditional. So if a figure is a rectangle with sides 2 and 3, then it has a perimeter of 10. So the figure is a rectangle with sides 2 and 3. That's going to represent our hypothesis. Then it has a perimeter of 10 is going to represent our conclusion. So that statement right there would be represented as if P, then Q. And that's how that would be read. So using those two variables, P and Q, for the hypothesis conclusion, that would be if P, then Q. First is the converse. And I kind of mentioned it above when we talked about the Thanksgiving one. The converse takes the hypothesis and conclusion and flips them. So the converse is if Q, then P. And I'm going to write out the converse, and we'll look at its truth value. We'll see if it's true or false. So the converse flips. So if, in this case, if a figure has a perimeter of 10, then it's a rectangle with sides 2 and 3. I know I'm not going word for word about there, but that's basically the gist of it. So if a figure has a perimeter of 10, then it's a rectangle with sides 2 and 3. So the converse takes the conclusion, writes it as the hypothesis, takes the hypothesis, flips it around, writes it as the conclusion. Now you got to check. If you have a figure with perimeter 10, does that mean it's a rectangle with sides 2 and 3? Is that true? No. So who's got a counterexample for me? How about a square? What would the square sides have to be to add up to 10? 2.5. Square with sides of 2.5. That's going to be my counterexample. Next, we get to the inverse. The inverse takes the conditional and it does what's called negate it, which in English means it makes it negative. So it puts the word not or un, something that makes the words negative. So for the inverse, I could say, if a figure is not a rectangle with sides 2 centimeters and 3 centimeters, then it does not have a perimeter of 10. So I'm just using that word not, or I'm using something to negate my statement. I'm going to kind of just abbreviate again because oops, 2 and 3. Then it does not have a perimeter of 10. I'm going to put P equals 10. So now we're saying if you do not have a rectangle with the sides 2 and 3, then there is no possibility that you could have a perimeter of 10. So if you don't have a rectangle with sides 2 and 3, could we still have another figure that has a perimeter of 10?
Yeah.
Yeah, sure could. So we have to say false again, and that's not true. That's going to be false. We could use square again. So you could use a square with 2.5, but maybe we want to say, let's do a pentagon with sides 2. Because a pentagon has 5, and if all sides are, pentagon has 5 sides, each of them is 2, all those are going to add up to 10. So the inverse is also going to be false because just because we're going to eliminate a rectangle with sides 2 and 3, there could be a pentagon with sides 2 that would work as well. Even if you had a rectangle, maybe you had a rectangle with one side 1 and 4, that would also work as well as a counterexample. Lastly, then, is the contrapositive. Contrapositive takes the converse and negates the converse. So if not Q, then not P. So we're taking that converse and we're going to negate both of those. So to help me with the contrapositive, and when I looked at the inverse, I was kind of looking at the conditional up here. To help me with the contrapositive, I'm going to look at this converse and I'm going to negate it. So we're going to say if a figure does not have a perimeter of 10, then it is not a rectangle with those sides 2 and 3. So in this statement, we're saying that the figure cannot have a perimeter of 10. So is it not then a rectangle with sides 2 and 3? So if we eliminate the perimeters of 10, then yes, we're not dealing with a rectangle 2 and 3. That one is going to be a true statement. So we've got our conditional. I should probably go up and should have said that first. Our conditional was true. Converse is false. Inverse is false. Contrapositive would also be true. You'll notice that pattern. If your conditional is true, your contrapositive will be true. If your converse is false, your inverse will also be false. But sometimes they could all be true. So you'll see the different patterns there. So you'll have one to try on your own. I like to use the P and Q. That's up to you if you want to add that to your notes anywhere to kind of help organize where the hypothesis goes, conclusion goes in each of those statements. Helps to kind of organize out your information a little bit. And then you can kind of see the patterns that the converse and the contrapositive are similar, except you're using the negation. The conditional and the inverse are very similar, except again, you're negating both of those statements as well. So we'll use the last about 20 minutes here. You have to work on your 2.2. Hopefully that kind of gives you a little head start. And then I will be coming around to help with any questions, but the rest of the time is yours.
I forgot to ask, should I have left that up